So today we're going to be investigating parallel and perpendicular lines. Parallel lines are lines that never intersect, and perpendicular lines are lines that intersect at a 90-degree angle. Now we have four graphs right here, and in the table provided under them, we want to fill out the slopes of each line and answer the questions that follow. So if we look at graph A, line number 1, we want to find our slope. So I'm going to find 2 points to use and do rise over run. So I'll use our x-intercept point and our y-intercept point for line 1 and create my triangle. So we go 1, 2, 3, 4, 5, 6 points we are rising, and we're running to the right 1, 2, 3. So when they simplify this, 6 over 3 is equal to 2. So our slope of line 1 is 2. And if we investigate our second line, again, I'll use the perfect points of our x and y intercepts. If I create our triangle, you can see we go up 1, 2, 3, 4 is our rise, and we run to the right 2 spots. So for line 2, our slope is 2. Now if I go ahead, I can go down and fill this table out. Slope 1 for graph A was 2, and slope 2 for graph A was also 2. Now if we take a look at graph B, line 1, if we're trying to find our slope, we can see that this is a straight horizontal line. So this is one of our special cases we went over last unit. So since it's a straight horizontal line, we have no slope. We're not going up or down in any direction. So for line 1, our slope is just equal to 0. And for line 2, the same thing can be said. Because it's not moving up or down, it's a horizontal line, our slope is 0. So I can go down to our table, and for graph B, slope 1 was 0, and slope 2 was 0. Okay, so now let's go ahead and look at our third graph, graph C. So if we look closely at this for line 1, we have a perfect point right here at negative 1, 2, and at our y-intercept at 0, 8. So to find our slope, we have our rise over run. We're rising up 1, 2, 3, 4, 5, 6 spots, and we're running to the right 1. So our slope for line 1 is just 6. And if we look at line 2, we have a perfect mark at our x-intercept that we can use and at our y-intercept. So if we count the rise, it's 1, 2, 3, 4, 5, 6. And the run is 1. So again, we have 6 over 1, which would just be 6. So our slopes that we want to put on our table for C are both 6. And now let's look at our last graph. For line 1, we have perfect points at our x and y intercepts. So if we do the rise over run, our rise is 1, 2, 3, 4. And our run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if we reduce this, it would be 2 fifths. Now if we go ahead and look at our second line, again we have perfect points at our intercepts. So our rise here is 1, 2, 3, 4. And our run is 1, 2, 3, 4. So if we simplify this, 4 over 4 is just equal to 1. So to fill out our table, our first slope for graph D is 2 fifths. And our second line slope is just 1. So now that we have filled out our table, we can go ahead and look at these questions. It says, what patterns do we notice about the slopes? Do all slopes fit this pattern? Why or why not? And what rule can we use when dealing with parallel lines? Now, if we look, slopes 1 and 2 for graphs A, B, and C are all the same, but our slopes for our lines 1 and 2 for graph D are different. So if we go back and take a look, like I said, A, B, and C all have the same slopes for their two lines. And when we look a little bit further at D, we can see that they do not have the same slopes like we determined. And if we look closely at our graphs, we can see that A, B, and C are lines that will not intersect, which is our definition for parallel lines. And if we look at graph D, we can see that eventually our lines would meet. Because if I go ahead, I'll put this graph into view. If I were to extend our lines, line 1 and line 2, we would meet. We would cross over right here. So, from our definition, we can tell that graph D does not have parallel lines. So if we go back down to the questions they were asking, we could say that we've noticed most graphs have the same slope for each line. Now it says, do all the slopes fit this pattern? We noticed that graph D did not, so no. Graph D did not fit this pattern. And for why or why not, we determined that it is not parallel. Now for our last one, what rule can we use when dealing with parallel lines? We can say that parallel lines have the same slope. So now we're going to investigate parallel lines. So it says each graph below contains two lines, and in the table provided under the four graphs, fill out the slopes of each line and answer the questions that follow. So again, I'm going to look at line 1 for our graph A and find two perfect points. I can see a perfect point is at our y-intercept, and we have a perfect point at 3, 7. So if we do rise over run, our rise is 1, 2, 3, 4, 5, 6. And our run is 3. 1, 2, 3. So if we simplify this, 6 over 3 is just equal to 2. Now if we go ahead and look at line 2 and we want to find perfect points. I see one right here at negative 6, 3. And another one at negative 2, 1. And this one, our rise over run should be negative because instead of rising up, we're moving down 1, 2 spots. So we have a negative 2 for our rise, and our run is 1, 2, 3, 4. So if we simplify this, negative 2 over 4 is equal to a negative 1/2. So if we go down to our table and fill it out, slope 1 of graph A was 2, and slope 2 of graph A was negative 1/2. We look at graph B, line 1, and find two perfect spots. We have one at 4, 8, and another perfect line at 3, 5. Do rise over run. We rise up 1, 2, 3, and we run once. So our slope is 3 over 1, or just 3. And for graph number 2, we want to find 2 perfect points. We have one right here at the origin, and we also have one at 3, -1. Rise over run is going down. So from here we can see that our rise is going down, and we're going down 1, so it would be a -1. And then we're running to the right 1, 2, 3 spots. So our slope for line 2 would be -1/3. So if we go ahead and fill this out in our table, slope 1 for graph B is 3, and slope 2 for graph B is -1/3. Okay, so now we're going to look at graph C. If we look at line 1, again, we can see that this is a horizontal line. We do not deviate up or down at all, so our slope for line 1 is just equal to 0. That was one of our special cases we learned last unit. And if we look at line 2, we can see that it is straight up and down. So it's a vertical line. And if we recall from last unit, this is one of our special cases where our slope would be undefined. So if I go to write this in our table, we would have 0 and then undefined. And lastly, let's look at graph D. Line 1, I'll find 2 perfect spots. There's one at the intercept, y-intercept, and there is also one at -1, 7. If we look at our rise, it's going down, so we'll have a negative rise of 1, 2, 3, 4. And our run is 1. So our slope for line 1 is just -4. And for line 2, a perfect spot is at our y-intercept and at 4, -2. Our slope is rising up 1, and then to the right 1, 2, 3, 4. So our slope would be 1/4. And if I go ahead and plug that into our table, it would be -4 and 1/4. So now we want to look at the 3 questions. So for our first question, what pattern do you notice about the slopes? So if we look closely at each graph, so for A we had a slope of 2 and a slope of -1/2. For graph B we had a slope of 3 and -1/3. For C we had a slope of 0 and undefined. And for graph D we had slope -4 and 1/4. So a pattern that we can see is that from each of them our sign has changed and it has flipped into a fraction. Because even if we look at these, the whole numbers, so our 2, 3, 0, and -4, could all be written over 1. So I could have, so I would have 2 over 1, 3 over 1, 0 over 1, and -4 over 1. And it's still the same thing. So for a pattern, we could say that the signs change and the fraction flips. Now for our second question, do all the slopes fit this pattern? Well, we can definitely see that graphs A, B, and D fit this pattern, but it could be a little confusing for graph C. Now remember, undefined means that our bottom part of the fraction, the denominator, is 0. So we have some number over 0. And same thing when we have 0. It doesn't always have to be over 1. It could be over any number. So if we choose x, that is fine. So if we look at these a little bit further, graph C does in fact fit this pattern. Now for our third question, what rule can we use when dealing with perpendicular lines? We can say that the sign change and the fraction flips, which is also known as a negative reciprocal.